Hello dear students, in this video we are going to discuss Bayes theorem, important problems. Okay, now let's see here question. Elaborated blood test is 99% effective in detecting certain disease when it is in fact present. So if it is in fact present any disease, definitely it will detect 99%. Okay, in fact it is present. If it is present, definitely it will detect certain disease 99%, 100%. Out of 100, 99% will detect. Okay, next, a test also yields a false positive result of 0.5% of healthy person tested, and if 0.1% of population actually has the disease, so here 0.1% of population actually has the disease, what is the probability that the person has a disease given that his test result is positive? So he is talking about a person having disease and a person not having disease. Okay, let us consider E1 is the event. Okay, E1 is the event of selecting a person having disease. Okay, E2 is a event of selecting healthy person, which means not having disease. Okay, healthy person, and here is saying test results is positive, is talking about the positive result or negative result. He is only talking about the positive result. Okay, now let's see here, let's draw. So a person, what is the probability having a person disease? A person having disease, 0.1% of population actually has a disease. So we are talking about the person having disease. So P of E1 is 0.1%. Okay, next, not having the disease is what? 100% minus 0.1%, which is 99.9% not having disease. Okay, now next, conditional probability. What is the conditional probability here? He is asking test result is positive. So A is the event of getting positive result. Okay, then conditional probability, getting positive result when a person having disease. Even is having disease now. So person, even probability of getting positive result when a person having disease is given already. What is given? 99% it will detect if a person having disease, right? So therefore 99% it has a disease. Next, getting a positive result when we tested a healthy person not having disease is already given. What is given here? 0.5% of healthy person is tested. Okay, so 0.5% yields positive result. False positive result, even still this is positive result. Okay, this is positive result for healthy person. So 0.5%. So 0.5%. So here these all given percentage, in terms of percent is given, right? So we will write P of E1 is equals to 0.1% can be written as P of E1 is equals, if I cancel this point I'll get by 10. If I remove the percentage I'll get 100 into 10, 1000. So can I write directly P of E1 is 1 by 1000. The same way P of E2 is what? P of E2 is 99.9 by 100. If I remove the decimal I'll get by 10. So 10 into 100, 1000. Okay, so this is 999 by 1000. And next, P of A by E1 is equals to 99%. If I remove the percentage I'll get the 100, but I need denominator 1000. I'll multiply 10, divide 10. So 990 divided by 1000. Okay, next, P of A by E2 is equals to 0.5%. If I remove the percentage I'll get 100. So if I remove the decimal I'll get 5 by 1000. Okay, So I got P of A by E1, P of A by E2. What is asking actually in the question? What is the probability the person has a disease given that his result is positive? So he's asking result is positive. This one is asking. Okay. So result is positive having the person disease. So E1 by A is asking. Okay. Getting, see here. So he is asking E1 by A. E1 by A means what is the probability of a diseased person got tested positive? Okay, according to the Bayes theorem, P of E1 into P of A by E1 divided by P of E1 into P of A by E1 plus P of E2 into P of A by E2. Okay, so we know here P of E1 0.1%, which is 1 by 1000, right? 1 by 1000 into 1 by 1000 into 990 by 1000, 990 by 1000 divided by 1 by 1000 into 990 by 1000 plus P of E2 is what? P of E2 is 999 by 1000 into P of A by E2 is 5 by 1000. 5 by 1000. So 1000 into 1000, 10 to the power of 6. So here take common and cancel. 990 divided by 990 plus 5 nines are 45. 5 nines are 45 plus 4, 49, right? 5 nines are 45 plus 4, 49, right? 4995. So if I add up this 4995, 990, so 5, this is 18, 19, 1 carries 59, so 990 divided by 5985. Okay, if I cancel with 9 table, so here 9 ones are 9 ones are, so here 9 6 are 9 6 are 5 are. Okay, so if I cancel with 5 table, 5 twos are 10, 5 twos are 10 divided by 5 ones are 5, 1 carries here, 5 threes are 15, 1 carries here, 5 threes are 15, so 22 by 133. So probability of diseased person got positive result is 22 by 133. Okay, this is the solution. That's all. So we have here second question. Suppose the reliability of HIV test is specified as follow. Of people having HIV, 90% of test detects the disease. If the person having HIV, definitely 90% it will detects, okay, the disease. 90% it will detects the disease if a person having HIV. Okay, next. But 10% go undetected of people free of HIV. So 99% of the tests are judged as negative HIV, but 1% are diagnosed as positive. Okay, from a large population of which 0.1% have HIV. 0.1% have HIV. 0.1% have HIV. 1% selected at random. Given that HIV test, the pathogenic reports him or her positive, what is the probability that the person actually has HIV? So let us see here. First we have to consider E1 is the event of selecting person having HIV. Okay, E1 is the event of selecting person having HIV. Person having HIV. Okay, E2 is a person having not HIV. Okay, person selected not having HIV. Okay, so we will write now. So this is probability of person having HIV is 0.1% is given. 0.1% is given, which is 1 by 1000. Previously we discussed, right? In the same way, uh, if a person is not having HIV is 100 minus 0.1%, right, which is 99.9%. This can be written as 999 by 1000. Okay, next. Now result. A is the event of getting positive result. Okay, A is the event of getting positive result. Okay, so here E1 by A1. So getting positive result when a deceased person got tested is what? What is the probability of A when E1 is given? So here, what is the probability of positive result when a deceased person got tested? So 99% it will detect na, 99%. So 90%, sorry, 90% test detects the disease. So 90%, which is 90 by 100. So we can write this as a 90 by 100. Right, 90 by 100, can I write in simple way? So 90 by 100 can I write in terms of 1000 denominator. So 900 by 1000. Okay, so next, probability of getting positive result when healthy person got tested. Okay, not having HIV person got tested, then what is the probability? So here 1%, see the question carefully, 1% are diagnosed as showing positive. Okay, so 99% of the tests are just negative, but 1% are diagnosed as positive result. Here is saying here 1% got tested. So here 1%, which is 1% is 1 by 1% is 1 by 100. 1 by 100. So in denominator we have 1000. I'll multiply divide by 10. So 10 by 1000. So we got P of E1, P of E2, P of E2, P of A by 1, P of A by E2. What is asking here? Pathogenic report says what is the probability that the person actually has HIV, got positive. So person having HIV, E1 by is asking this. Okay, E1 by. So E1 is the person having HIV. What is the probability of person having HIV when he got positive result? Is according to Bayes theorem, P of E1 into P of A by E1 whole divided by P of E1 into P of A by E1 plus P of E2 into P of A by E2. Okay, so according to this Bayes formula, so 1 by 1000 into 1 by 1000 into 900 by 1000, 900 by 1000 whole divided by 999, 909, 1 by 1000 into 900 by 1000 plus 999, 999 by 1000 into 10 by 1000, 10 by 1000. Therefore here this is total probability. Okay, this is total probability, this is a required probability. So here 1000 into 1000, 1000 into 1000, 1000 into 1000, take common and cancel, you will get 900 divided by 900 plus 919, 9 into 10, which is 9910. Okay, so if I add up this 990, 999, 0 and 900, add up this 0, this is 9, this is 18, 10890. So 900 into 10890. Okay, here 0 0 cancel, you'll get 90 by 1089. Okay, 1089. So if I divide this, let us say 90, 1089. So if I put point, 0, not enough, so 0 0. This is 8 times. Okay, 0 point, you'll get 0.08, approximately 3 will say. Okay, approx. So therefore the result is here, probability that probability of diseased person got positive result is 0.083. Okay, this is the answer. Okay, this is the final answer.